Salam, peace be upon you. My name is Muhammad Laik Sediki, the father of Holophase. We have already certified a severe set of rules together, and we are not allowed to forget them. We only speak inside licensed finite windows with passports. We only speak if coherence passes the minimum threshold. We only speak if what we claim is identifiable from the data. We only speak up to the operational ceiling, the maximum legal depth, and anything above that is deleted. We only speak with priced uncertainty that can be audited or we revoke it. Now we enter the next layer, unwrapping so differentiation is even possible, without pretending the unwrapping is reality. Listen carefully, because Part 14 is one of those moments where a whole program either stays honest forever or it quietly turns into a magic trick. The moment we begin to differentiate, the moment we begin to say slope and curvature and higher structure, we face a very old trap. The trap is that the mathematics will offer us a convenient intermediate object, and our human mind will want to worship that intermediate object as if it were the thing itself. Our job is to use the convenience without believing it. That is what this part certifies. Our mission is simple to say and hard to live by. We must enable differentiation when the only primitive quantity we are allowed is phi, a cyclic comparability field. Spoken formally, phi is a mapping from the abstract events at X to the circle S1. That means phi values live on a circle, like an angle on a compass, like a hand on a clock, like a point on a ring. And our public meaning rule is still the same. Only differences in phi, delta phi, inside licensed windows are speakable. Absolute phi is mute. So far, so strict. Now comes the problem. Derivatives, even the first derivative, want a straight line. A derivative is about how much it changes per step. But if your values wrap around the circle, change has a built-in ambiguity at the wrap point. If something goes from 350 degrees to 10 degrees, did it go forward 20 degrees or backward 340 degrees? Your instrument might only tell you 10 and 350 because that is what a circle does. The circle forgets how many full turns happened. The circle only knows where you are modulo a full loop. This is not a side issue. This is the core issue, because episode 14 is a compiler. If anything can become public structure, it must pass through this pipeline. And differentiation is one of our main extraction tools. If we cannot do differentiation honestly on a circle, we cannot do the rest honestly either. So here is the essential certification of part 14 said in everyday language. To compute derivatives, we must temporarily unwrap the circle to a line, but only locally and only as a tool. That temporary unwrapping is called the lift. The lift is not reality, it is scaffolding. And because it is scaffolding, any output that depends on which lift we chose is not public structure. It is bookkeeping, it is rejected. If you want one image you can feel in your body, hold this. Imagine we are walking on a circular track, like a running track. And the track has markings, stripes, bumps, and patterns. We want to measure the pattern. But the track loops. If we insist on assigning each point a single number on a straight ruler, we must choose a place to cut the loop and lay it flat. The moment we do that, we have made a choice. If we cut at the starting line, the numbers run one way. If we cut at a different spot, the numbers shift. The track did not change, only our numbering changed. That numbering is a lift. It is useful because now we can talk about slope and second derivative of the pattern as a function of distance along the track. But if our conclusions change when we move the cut or shift the numbering by a constant, then our conclusions were never about the track. They were about our cut. That is the rule we certify. We are allowed to cut only to do local calculus, and then we must collapse away the cut. We keep only what survives the collapse. That survival is invariance. In our program, invariance is the stamp of public meaning. Now let's make it precise without turning it into chalkboard theater. We will speak the math in a way your ear can hold. Phi lives on S1, the circle. A lift is a new function. Call it phi tilde, that lives on the real line, the ordinary number line. Phi tilde is constructed so that if you wrap phi tilde back onto the circle, you recover phi. In other words, phi tilde agrees with phi modulo 2 pi, modulo a full turn. If you have heard mod, think wraparound. The circle does not care if you add a full turn. So phi and phi plus 2 pi are the same point on the circle. So we pick a local region inside the licensed window, and we choose a way to unwrap. That gives us phi tilde. Once we have phi tilde, we can differentiate it like a normal function. The derivative of phi tilde is what we will later read out as omega, the cadence, the rate of comparison change. The spatial texture readout we call kappa. The transport readout we call nu. Triunity is mandatory here. Every certified structure will have the omega readout, the kappa readout, and the nu readout as three faces of the same differentiation. But we are not allowed to call them time, space, or motion as primitives. They are only labels for readouts. Here is the catch. Phi tilde is not unique. Even inside the same patch, we can add the constant offset. Phi tilde prime equals phi tilde plus c, where c is any constant. If you shift your 0 point on the number line, the wrapped circle values do not change. The physical comparisons do not change. The data do not change. The passport does not change. Only the bookkeeping coordinate changes. So the first test of our honesty is this. If we compute something and it changes when we add a constant to the lift, then it is not public. It is lift dependent. It is rejected. But when we take a derivative, the constant disappears. The derivative of phi tilde plus c is the derivative of phi tilde. So derivatives, inside the domain where the lift is continuous and well-defined, are lift invariant under constant shifts. That is good. That is why the lift exists at all. It allows us to compute quantities that can survive the collapse back to the circle. But we must not get drunk on that fact and start saying, all derivatives are always safe everywhere. They are safe only where the lift is legitimate. And that is why this part also certifies domain typing. Every lift has a domain where it exists and stays continuous. Outside that domain, the derivative operator can become undefined. It is not wrong. It is undefined. We do not allow undefined to masquerade as a number. So part 14 is not we can now differentiate. Part 14 is we can now differentiate only after we certify lift existence, and we only keep what is invariant under lift equivalence, and we must type the domain where this is valid. Now let's plug part 14 into the compulsory toolchain line, because we are required to keep the pipeline alive in the listener's mind. Here is the pipeline spoken as one line. Licensed window, then passport and coherence and identifiability, then nmax and uncertainty, then local lift, then cuts if needed, then excisions, then certified domain D, then A equals D phi tilde, then finite jets up to nmax, then invariance collapse, then topology and defects, then invariant basis, then stability and entities, then scale stratification, then escape test, then handoff. You hear where we are. We are at local lift. We are not yet at branch cuts or excision, but we are laying the groundwork so those parts can be strict later. Now let's make the whole thing emotionally real with a simple story from everyday life. The clock on the wall. Time of day lives on a circle. After 12, it goes back to 1. If we only know clock readings, we cannot tell how many full days passed between two readings. If we want a rate, like how fast is something changing per hour, we must unwrap the clock into a running count of hours. That running count is a lift. We might set midnight as 0 hours, then count upward. Another person might set noon as 0. Another might use a different time zone. Those are all lifts. If our claim depends on which of those choices we made, it is not public structure. But if our claim is about the rate of change that any lift would agree on inside the local window, then it is public. That is the exact same logic we apply to phi. Phi is a cyclic order. We unwrap only long enough to take local rates, textures, and drift readouts, and then we collapse away the arbitrary offset. Now let's do the first gate explicitly, because part 14 must be a gate enforcing part, not a poetic essay. Gate 1 is the lift existence gate. This gate asks one blunt question. Inside this licensed window, can we actually construct a continuous local lift that matches the measured delta phi comparisons? If not, we cannot differentiate here, period. We do not approximate anyway. We do not assume continuity. We refuse extraction. How do we decide lift existence in plain language? We look at our comparator data, which comes as differences around loops. If you go around a small loop in your comparison graph and the net wrap change does not come back consistently, you have a residue. You have an obstruction. That means a single continuous unwrapping cannot cover that loop without a jump. That is not a failure of nature. That is a truth about the domain. It means you are at the edge of where smooth unwrapping is safe. And that is exactly why we later need branch cuts and excision. But part 14's job is to ensure we do not pretend the lift exists where it does not. Gate 2 is the invariance gate under lift shifts. This gate is merciless. We take a lift phi tilde and we create alternative lifts that are lift equivalent. The simplest lift shift is adding a constant offset. Another is adding an integer number of full turns, 2 pi times an integer, in a way that does not change wrapped values. We then recompute the observable. If the observable changes, we stamp it as bookkeeping and we reject it from the certified set. The rule is, only lift invariant results survive as public structure. Gate 3 is domain typing. We must report explicitly where the lift is valid, where it might fail, and where the derivative operator becomes undefined. This prevents a common fraud that is often not intentional. People compute derivatives across discontinuities and then interpret spikes as real physics, when the spikes are simply U differentiated across a seam. In our language, that seam is where the lift is not smooth. Domain typing is the honesty layer that says, calculus is only safe here and unsafe there. And we do not pretend otherwise. Now let's state the prediction without dynamics, in the only way episode 14 allows. We do not predict future events. We predict forbiddenness footprints. Here is the part 14 prediction. Any method that claims to compute a derivative of cyclic phi without constructing a local lift will either secretly choose a lift in disguise, or will fail in variance tests, or will become undefined at exactly the seams where lift existence fails. In other words, lift-free derivative claims will collapse under audit. You can see this with the simplest example. Suppose we have two wrapped values, 10 degrees and 350 degrees. A naive difference says 340. But a locally consistent unwrapping, given the assumption that the change between samples is small, says minus 20. The naive method is not lift-free. It is just a bad hidden lift choice. Under small changes in sampling, it flips. Under a different branch choice, it changes. Under a different lift convention, it changes. So it fails in variance. That is exactly what our prediction says will happen. Now the falsifier. Part 14 is falsifiable. Here is the falsifier, spoken simply. If someone produces a genuinely lift-free derivative operator that takes only wrapped cyclic data as input, never anchors any branch, never performs hidden unwrapping, works wherever lifts exist, and produces outputs that match the ordinary derivative outputs we would get from any valid local lift, then our lift discipline would be unnecessary or incomplete. That would force an extension or revision of this part. We invite that challenge because we are not building a mythology, we are building a compiler. Now we must include an explicit invariance stress test, because that is mandatory. Here is the stress test we certify in part 14. Take phi and add a constant offset everywhere. Phi goes to phi plus constant. Rep values do not change in any meaningful way. Construct a lift phi tilde. Now construct another lift phi tilde prime equals phi tilde plus constant. Compute omega, the derivative readout, from both. They must match within declared uncertainty. Next, change charts. Choose a different local unwrapping convention that still respects the same delta phi data inside the domain. Compute the derivative jets up to the allowed n max. They must match wherever the domain overlaps and the lift is smooth. If they do not match, the output is lift dependent and must be rejected. Notice what we are doing. We are not proving something about the universe. We are proving something about public readability. We are building a method that refuses to let coordinate tricks become claims. Now let's zoom out across scales, because you asked for powerful analogies across scales, and because this is not a niche technical issue. The lift problem is the same, whether you are unwrapping a compass bearing, unwrapping a phase in an interferometer, unwrapping a daily clock, unwrapping a circular dial, or unwrapping a repeating pattern in a dataset. The scale does not matter. What matters is this. The raw data has a wraparound symmetry, and we want derivatives. And derivatives require an unwrapped local line. That is universal. At a human scale, it is like measuring directions in a city with only turn left and turn right instructions, without a fixed north. To draw a map, you choose a north, you unwrap directions into coordinates, you compute slopes of streets, you compute curvature of the path. But you must keep track that north was a convention. If your street slope changes when you rotate the map, you did not measure the street, you measured your choice of orientation. The public structure is what survives rotation. The same thing happens with lift shifts. At a biological scale, it is like analyzing a repeating genetic sequence motif where the pattern wraps. You can index it from any starting point. If your features depend on where you declared the start, your features are not real. Real features survive a circular shift. That is invariance under lift equivalence in another costume. At a cosmic scale, it is like measuring a repeating wave pattern where only phase differences are accessible. You can slide the phase origin anywhere. If your conclusion depends on your chosen zero phase, it is bookkeeping. Real structure is in the rate of phase change, the pattern of variation, the invariant features of the phase differences. So part 14 is giving us a universal discipline. Introduce the scaffolding only to compute invariant outputs. Then throw the scaffolding away. Now we must connect this to the holophase ontology lock, because we cannot let the listener forget that we only have one primitive. We are not adding geometry primitives. We are not adding distance. We are not adding a metric. We are not adding curvature. We are not adding causal order. We are not adding time evolution. A lift is not a new primitive. A lift is a computational representation inside a window so that the derivative operator can be applied. And any output that depends on which representation we used is non-public. That is how we unwrap without new ontology. Now we must state the carry line, because this is what the listener should walk away holding. Here is the carry. We unwrap locally, and only invariants survive. We do not worship the lift. We do not argue about the lift. We only use it, test invariants, and keep what survives. Now, before we end, we must specify the audit artifact and the revocation clause, because episode 14 is a ledger, not a sermon. Here is the audit artifact for part 14, spoken as what goes into the ledger. The ledger must include the passport identifier for the window. It must include the coherence status gamma and whether it passed the minimum. It must include the identifiability status and the certified Nmax for that window. It must include the uncertainty lineage that applies to the lift construction and derivative extraction. It must include a lift existence map, where a continuous lift was constructed and where lift existence failed or was not attempted. It must include the explicit lift equivalence tests, at least one constant shift test, at least one alternative lift construction in the overlap domain, and the invariance results. It must include the domain typing, the certified domain D, where the lift is continuous and differentiation is defined, and any boundaries or seams where the operator becomes undefined. It must include either the outputs produced, flagged as lift invariant, or a refusal certificate that says lift does not exist here, or invariance failed, with a failure classification. And here is the revocation clause, stated sharply. If any observable in the certified set is later shown to change under lift equivalent choices within the same type domain, that observable is revoked and removed as bookkeeping. If any derivative was computed outside the type domain where the lift is continuous, that output is revoked as an illegal use of the operator. If any lift construction is undocumented or cannot be replicated from the passported data, the derivative outputs are revoked. We do not patch around this. We do not soften it. We revoke, archive the failure in the negative ledger, and we proceed with a clean compiler. That completes what part 14 must certify. Differentiation on the circle is only possible through local unwrapping, and unwrapping is never reality. Only lift invariant results survive as public structure, and everything else is bookkeeping that we refuse. And one final practical note for the listener who wants the deeper formal machinery behind what we just narrated. If you want the formal work, the definitions, the proofs, and the audit templates in their strict mathematical form, you can find them on Zenodo by searching for holophase. Next, we will face the reason lifts cannot always be global, branch cuts. Part 15 will install the branch cut protocol so that when unwrapping cannot be done everywhere at once, we still do not lie and we still keep only invariants.